Okay, so good evening, everybody, and good morning at the time zone. My name is Rawson, and we are here for this workshop to understand the storage services, the cloud storage services. Where do we store data, right? And we're going to understand from a performance perspective, and we're going to understand from a reliability perspective. So, in cloud, right? Particularly in AWS, we have got these three storage services. Uh, Before I get started with this, um, can anybody help me understand? I just want to understand. Everybody understands cloud. What do we mean by cloud? And what is on-prem? What is the difference here? Do we understand this so that we can take it from there and then we will talk more? Do we understand everybody? Yes or no? Would help here.
Yes.
Okay, great. How about others? If anybody doesn't
Yes,
understand,
I understand, sir.
good. Uh, if anybody doesn't understand, please mention no. I'll just take a minute, okay? So when we say cloud, right? Before cloud, we had something called on-prem. So whenever we compare cloud, we always talk about compare with on-prem. So on-prem is something you set up, the company set up, and they will procure they will set up the data center, they will procure the land, they will construct the building, the infrastructure, they will purchase all the hardware, storage services, network, security services, like security personnels. So because for the security of the facility, right? So you have to procure, you have to purchase everything. And that's what we call it on-prem. The data center concepts, it's the same. On-prem means when you set it up. That's called on-prem. And when somebody else has set it up, right? Like AWS, Amazon Web Services, or Microsoft, or Google, right? They have their own cloud. Oracle, right? Alibaba, right? DigitalOcean, you might have heard of this. So what they have done, they have set up their data centers like a business model, and we users can go and ask, use like a rent, right? Like how we stay in a rented apartment. Somebody else owns the apartment, right? The flat, but we can stay there as long as we pay the rent, right? Same thing happens for the cloud. You can use the services that is there in the data center, like servers, storage, and a lot of other details. We have a lot of services. We can use it as long as we pay the monthly bill, right? That's what the fundamental difference. Here we don't own in the cloud, we don't own anything. Like when we stay in a rented apartment, we don't own the apartment, right? But we can use it as long as we are paying the monthly rent, right? Same thing for the cloud. As long as we are paying the monthly bill of all the services, of all the compute, of all the storage services, we can continue to use. The moment we stop paying, they will stop the services. They will not be function. They will not be operational for us. That's the fundamental difference. I hope you had the same kind of concept, right? Yes, everybody?
Yep.
Okay, good. So now, why we use cloud? Because not everybody can set up the data center, right? We cannot set up my own on-prem. And that's why you see a lot of startups, because it's a very huge, costly affair. We need to invest billions of dollars. Think about, right? When you think about own on-prem, you have to procure the land, construct the facility, the infrastructure, purchase all these servers. You have to do maintain, lot of cost involved, billions of dollars to set up a data center. Not everybody can afford, right? So what we do, let's say if I have an idea, I can use some cloud services. I could use any cloud, AWS, Azure, GCP. I have multiple options. We customers have multiple options we can use. But what is required? We should know how to use it. So this is what I am showing you, the management console. So every cloud service provider, they have given us this console. You can log in, I have logged into AWS. If you can also create your own account in AWS, Azure, GCP, like every cloud service provider, they have given this free credit kind of a thing for 1 month, 2 months, 3 months, for 1 year. They have given something free for us to learn. We can leverage those, right? So right now, what you see is the management console of AWS, right? I have logged in. So we should know this. If we want to use the cloud, we should know this services. So somebody asked, do you know cloud? Basically, I'm asking, do we know how to use this? If I if you need a server, right? The fundamental thing. Why do we use cloud? I have the code with me, but I want some server where I can deploy my code, right? I have data with me. Netflix has a lot of content, movies, like a lot of content, Hotstar, like they have a lot of content. They want some storage, right? A lot, petabytes of data storage. They can have their own data center. Again, it's going to be very costly, but I can use cloud and I can use. So cloud has servers. I can get some servers to deploy my application. I can get some storage to store my data, right? Similarly, a lot of other features are there, right? If you look at the services here, if I just click on the services, you're going to find a lot of services here. Lot of services. Compute is for the servers. Then you have got storage. Now it is developing, right? Machine learning for IoT, for game development, for everything, for database, for containers, for everything, there is a service. This is what cloud provides. And a lot of the cloud provides security features also. There are a lot of services for security features also. A lot of features. Networking, right? So that's why people use cloud. So today focus is on the storage, right? So if you look at the storage, so primarily in AWS, okay, so far so good. Please give me a thumbs up. Any questions so far? Yeah, guys, if you could give me a thumbs up, I can be confident and I can move ahead. Good, thank you. So today's focus is on the storage services, right? So primarily in AWS, we have got three storage services. EBS, which is called Elastic Block Store. Full form is Elastic Block Store. We have got EFS, which is like a Elastic File System. And we have got S3, which is like a simple storage service. I'll give you some use case, then you'll understand better, right? Three storage services, primarily in AWS. If you go to Azure, the use case would remain the same. The name would change. They don't call it EBS, right? They use some other terms. They don't use the word EFS. They use some other words, right? If you go to S3, but the use case would remain the same. What the use case I'm going to tell you right now, the use case. When do we use EBS? Because the use case would not change. So for example, if you are provisioning a server, right now your laptop, consider like you're configuring your laptop. So usually what type of hard disk we opt for nowadays? What type of hard disk we use nowadays? It is HDD or SSD. What type of hard disk we opt without laptop nowadays?
Mostly SSD.
SSD, right? So this is what EBS we call it. So whenever we are getting a server, right? Because when we are getting a server, the server will have an operating system. And where that operating system would be hosted. I need some storage, right? So for example, if I need a server, I can go to EC2 here. EC2 is a service name, which is called Elastic Compute Cloud. If I'm getting a server, EC2 is the virtual servers in the cloud. So during the EC2, get provisioning EC2, you have an option of storage. That storage is EBS. So this use case would not change. If either you're using Azure or GCP, whatever you're using, The use case is same. Everywhere you're using this, everywhere you're provisioning the server, and you need the storage, and that storage is called EBS. So I'm launching an instance, and I'll just show you at the down what you have. What you see here, configure storage. Because this is where your operating system is going to host. Operating system doesn't get installed on the RAM, right? Operating system doesn't get installed on the compute processor, right? In your laptop right now, you know where your operating system is there, right? In your hard disk, if I take your hard disk from your laptop, you would not be able to boot your laptop, right? Because operating system is the hard, it's in the hard disk, which is SSD. Same thing. So the use case of EBS is that we call it boot volume, basically. That we call it boot volume, right? Now, where else? So that is very important. So because this has to be fast, I cannot go for HDD. We have an option right now. If you look at the EBS option, I'll show you. So if you go to AWS EBS, just see here, you have got multiple options. You have HDD options also. Let me show you the documentation, then you'll understand what I'm talking about. So this is the EBS page, okay? You have HDD options also. But usually what do? We select GP2 or GP3, which is SSD. GP2, general purpose, full form, right? SSD based. So again, there are multiple options in SSD also. Earlier, we were using HDD. In HDD, we have two options in AWS. I'm talking about AWS today, okay? I'm not talking about any other cloud. I'm specifically talking to AWS. We have similar things in other for the other cloud providers. We have the similar things. So in HDD, we have two options in AWS, ST1 and SC1, right? So it all depends on how much fast, right? Why we go with SSD? Because the IOPS is fast, right? The read and write. See, whenever we use the word disk, what is important from a performance perspective is the read throughput and the write throughput. If the write throughput is going to be slow, means your inserts, right? Your inserts or update or delete, that's the write throughput, right? These three operations talk about your write. You're updating something in the database. That's going to be slow. Obviously, if you're using HDD also in your application, your performance will also be slow because of the disk issue, because your IOPS are slow. That's why we don't use HDD in our laptop also. Same thing if you're using your application in the databases. So what I'm trying to tell you, the other use case of EBS is your databases. Normally, whatever the database that we use, right? In our application, we mostly use SSD. We don't use HDD because in our application databases, let me be specific, application databases, when we configure the application, right? Let's say 3-tier application, web server, application server, database server. This is what I'm talking about here. So other use case of EBS. Because if this guy is slow, if I'm using HDD here, I cannot expect my performance to be fast, right? The writes will happen slow. The reads, the select queries will happen slow, right? So this is what we need to understand. And based on the my requirement, so we have got many options, right? Let's talk about SSD because this is what we mostly use nowadays. We don't talk about HDD. Earlier we were using, and there were some other generations also. So let's focus on the SSD. So GP2 and GP3, general purpose 2 and general purpose 3 are mostly used. And you can see the use case where all we use this EBS. So virtual desktops, I told you, right? Boot volumes, low latency interactive applications, boot volumes, development and test environments, transactional workloads, we use this. We have even advanced in SSD also we have even advanced. We call it provisioned IOPS. It is going to be costlier, very much costlier as compared to your general purpose SSD. And they are used for IO intensive database workloads. So it all depends. So your requirement, when you have an application where you're seeing that your GP2 and GP3, let's say you need milliseconds response time, millisecond for all those retail applications. When we go to online, right, to purchase, we cannot afford to have a higher response time. So, and let's say you, while analysis, you found you're looking at and understanding that the most of the time is being spent on the database. It's not the query, it's the read write. More IO is happening, and the most time is happening at the read write. And your speed, because of the database type, you have the performance issue. So you need to think about these situations, because if IOPS are not better, your disk IOPS are not better, your performance is going to be how fast your application would perform. Your database from the database side, it's going to be slower. Obviously, we need to also look at the SQL query. If you can tune that, or indexing, or any other parameters, right? We need to also look at those things, sarding, those things also come. But I'm talking about from the infrastructure perspective. Your infrastructure has to be better to support you with lesser low latency. And these are the options: GP2, GP3. And what is the most important thing is the IOPS, input, output, the read and write, the inserts, the write. When I say write, I'm talking about inserts, update, and delete. When I'm talking about read, I'm talking about select, right? Mostly these are the four operations that happens in a database, right? Read and write. So it can support, GP2 can support up to 16,000 IOPS, right? And max throughput per volume is 250 MIB per second. If you go with IoT block express, it's going to be costliest of all. It can support up to 256,000 IOPS as well. It's going to be sub millisecond latency. You're going to be super fast with this, super fast, right? Again, the cost of the database would increase definitely, right? Sustain IOPS performance. More than, if you require more than 64,000 IOPS, you have to select that. Till 64,000 IOPS, your IO1 can be good enough. But if you need even more than 64,000 IOPS, you have to go with IoT Block Express, right? Same concept of why we went ahead with SSD over HDD. If you are working on some application, and if you think more IOPS is happening and you need more IO support, you need to consider these options, right? So these are the use cases of EBS. All are the use case of EBS. Making sense?
So, Roshan, I definitely understand this theoretically when you talk about this, but of course, I mean, few of us like never worked on the high scale application, right? So that's why we are coming here. Are we going to see this in practical somewhere, or we are just going to tell something like this, how it will be?
Now we are talking about right now overview of these things, right? Practical,
Okay.
when you say practical, what exactly? Do you want me to
So,
provision, IO, these kind of things, and show you the difference, those kind of things we're talking about? No, we are not going to do those things. They are very costly machines.
okay.
Unnecessary, we are not going to use that.
No, no, I don't wanted to see at least IOPS with IO2 or IO1. But
Yeah,
when
GP2, GP3, definitely, right? They are the very obviously. So if you're even getting the server, right? EC2.
Mhm.
EC2 also, I'm going to select GP2. That's GP2 or GP3 is our select are the best options. We always select GP2 or GP3. That's our normal SSD.
Yeah, but all I'm trying to ask is like, when I mean we are talking about the performance engineering, are we going to really generate some load stress or stress test against some of these services and see the difference in metrics somewhere, or how
Right
it's
now, for this workshop, no.
no, not with this workshop. I'm talking about if let's say if I enroll for this course,
Okay.
how it will look like in the future.
Okay. See,
I
there
I
is
think he
no.
is asking about
I got it. I got it.
use case
I got it. I got it.
implementation.
So the live. So you're talking about GP2 versus GP3 and increased performance. See, you need more storage also. See, the demo part. I understand what you're asking. You're asking about the demo part in the real course, right?
Yeah,
So again, to generate more IOPS, you need to have more storage also.
that's
So
correct.
right, because more the storage, more the IOPS. That's how these are burst type EBS volume. So we don't do that demo. I will talk about separately about the course, what is the course brings to the table, what value additions. We will keep that as a separate topic. Tomorrow we have a kind of a demo session. We will talk about the course. But to answer your question in brief, no, we don't do this performance test and compare GP2 versus GP3 live. We don't do that as a number.
Okay.
Yeah.
Okay, got it. Because I mean, the I thought it will be going to something like that, so we can compare the metrics in practical, so that it
No, no,
registered.
you
But
will
yeah, I
understand
got
about
it.
the course, what course brings to the table. I think you will understand it better
Yeah,
tomorrow. Because I'm
yeah,
talking
exactly.
about storage right now. In the course, we talk a holistic view. We talk at a different level. So you will understand better if you attend tomorrow's demo. Yeah.
Got it. Got it. Yeah.
Okay. So I'm going deep dive and talking about only about the storage today. Yeah.
Okay, understood.
Okay. So this is about the EBS. Okay. Is it making sense what I'm talking about for the EBS? Any other questions which I can clarify for you? Okay. I got from Anil, I got a thumbs up. Others, all good? Okay. Now, so primarily two use case. To summarize things of EBS, primarily two use case. Whenever we are getting a server, provisioning any server, because we use thousands of servers, we provision always. So we always select GP2 or GP3. We start with GP2. GP2 is also not bad performance, 16,000 IOPS, which is a good enough, right? For a server which is hosting some process Java application, 16,000 is more than good enough. It's only going to be applicable when you have a database. Because database is mostly we do read and write, right? So while selecting the database, because database is another service, right? So which I was talking about, right? We took a holistic view, right? So when we talk about databases, then we talk about other options, what AWS offers and what are the options we have. Simply because, so out of these two use case, when we create boot volume, we end up always select GP2. That's all we do. Mostly GP2, boot volume. I have never seen till now for boot volume anybody using IO1 or block express. No, I have not seen that such a use case. That's going to be very rare use case. In performance, we have other ways to achieve performance. We can use Redis, in-memory cache, right? We have other options also. But for server, GP2 or GP3 is more than good 99% of the case. We always use GP2 and GP3. These are, consider these things only for the databases. When we really need a database, and in database, we have what multiple options in AWS. So I'll talk about that in the course, right? We have got multiple options in the database. We have document DB, DynamoDB, Elastic Cache to improve the performance. We can use completely RAM. So see, we're talking about database, but think about a solution. I'm going to give you just a hint. Think about a solution. Forget about disk. What if I cache everything in the RAM? It's going to be much more fast. Even with IoT block express, even with IoT block express, if I store everything in the RAM, can this guy compete with that? No. RAM is always going to be very, very fast. So when we say in-memory cache, elastic cache, I'm talking about RAM. We always used to improve the performance. We cache data to the in-memory cache. we call it elastic cache, which is another kind of database. Okay, so I'm answering your question, though I could not get the name who was asking the question. Who was asking the question sometime back? It was Anil or Ajit? Could I get the name? Okay. Okay. Those the person, the last person, right? Those asking the question. So we use elastic cache. We don't go with IO2 block express. We use elastic cache, okay, to improve the performance. Now, coming to other options. So one is the boot volume, where we mostly use GP2 or GP3, right? And the application databases, we have got multiple options. First of all, we have multiple options in the databases. So I'm not going to deep dive here a lot. But remember, for each kind of use case, for database I'm talking about, we have got multiple options here. We have elastic cache. That's going to be whatever you require. Better performance, right? Millisecond, 20 millisecond response time. Everything we put in the cache, in the RAM. When we put in the cache, we mean the RAM, right? So this is going to give me the immense performance. But again, we have got EBS options. Still, I can use some GP3 and more the storage, more the IOPS. I can achieve that. So we need to do some performance test and understand what is our requirement, what is our SLA, and we can meet the requirements. We need to take that thing with the performance test and our business management. Okay, so far so good. Now I'm going to move into the next storage services, which is S3. Okay, I'm going to ask you a question. I hope everybody is aware of Netflix, Hotstar, right? Amazon Prime Videos. Everybody knows that. Do we know where they store their content? Any guesses? Absolutely. Yes, Anil, you are right. Others? Anybody else? I see Anil answering using the chat option. Others, you can also use the chat option. Yes, it is S3. All the content that you see of Netflix or Dropbox. Do we use Dropbox, guys? Anybody using Dropbox? Dropbox, Amazon Prime Videos. Obviously, it's from Amazon only, right? So, and Hotstar also. Okay, I have heard Hotstar as well. These are the primarily use case of S3. So what do we call S3 for? It is called storage, simple storage service. We also call it object storage. Object means anything you can store. Anything. You can store anything. It could be a media, it could be MP3, it could be a GIF file, it could be a tarball, anything. Whatever you can think of, object. Anything you can dump it in. So can't we dump anything in EBS? The question is this, can't we dump? You can dump, but it's going to be costlier than S3. EBS is much more fast. That's why the use case is very particular. See, the three options that we're talking about, they complement each other. They don't compete with each other. So people can ask why they have so many storage services. Why can't, already if we have EBS, why they have S3 or EFS? Yes, good question. But cost is at the center. Every decision, any architect that they decide, right, which one to go with, cost is at the center. How much performance is required? I have mentioned elastic cache. It's going to be a super costly thing. Do we really require 30 millisecond latency, double digit millisecond latency? The question is this: do we have in the SLA? Have we committed this to our customers that we need this much SLA, this much response time, latency? No. Let's say the answer is no. Then we don't need elastic cache because it's gonna put a lot of cost. Everything is driven by the cost. When you work, when you join a real company, right? A company, and when we talk about the real thing, right? How much is the budget? Every company struggles with the cost. Any company you join nowadays, I have seen in last 7 to 8 years, any company you join, everybody is going to do cost optimization. Every company, because these services cost a lot, and that's why these many storage services. It's not like I cannot use EBS to store my all my content. Yes, I can store, right? In my laptop, we store movies, right? But the question is, do we really require EBS that much IOPS to see the content of my movie? Not really. Even HDD is good enough. Remember, earlier days, did we struggle to watch movies in HDD? Did we struggle to watch movies in HDD? The answer is no. So basically, the use case of EBS is the boot volume. Boot volume where we host the OS. Because we want to reduce the, because that's the maximum operation that happens between the operating system and the disk. When we boot our laptop from the disk, operating system gets in the RAM, right? So the IOPS is happening between the RAM and the disk. And if we use HDD, our laptop is going to be slow throughout, right? So that's the use case. Storing movies, storing media is not the use case of EBS. That's the use case of S3. Mostly internally, AWS doesn't tell in the documentation, but mostly they use HDD here in S3. Nobody, they would not tell, but it is HDD. It is cost much more cheaper as compared to EBS. You can check the cost, 1 GB of EBS versus 1 GB of S3. You can see the difference and you will understand, because IOPS is not the concern here, right? Because we need petabytes of data here, terabytes, petabytes, multiple. Look at the Netflix, how much content they have, Amazon Prime Videos, how much content they have, right? They cannot afford to use EBS. It will be super costly. And it's not required that much IOPS for watching movies, right? Streaming platform, they do not require. So that's the use case of S3. So, right, in S3 also, to optimize the cost, I'll tell you about the performance. In S3 also, we have got multiple storage classes. In S3 itself, multiple storage classes. So we started with storage services, 3 storage services: EBS, S3, and EFS. In S3 itself, we have got multiple storage classes. What are those? S3 standard, multiple, 7, 8. I'll show you the one table. S3 standard, we have got Glacier. I'll tell you, in Glacier, we have got 2 options. We have S3 one zone. We have got multiple. I'm going to directly show you the link, the table. S3 one zone. Then we have deep archive. I'm just showing you 4, but we have 8 total. I just remember the important ones. Earlier, there used to be only 3 or 4, but they have increased a lot. So S3, let me just do one thing. S3 storage classes. Look at this. Why so many storage classes? Cost matters. Everything is at the cost. And obviously, how fast we need the data. So look at this S3 standard, S3 intelligent tiering, one zone, express one zone, standard infrequent access, one zone IA, glacier two things, instant retrieval and flexible retrieval, deep archive, S3 outposts, 10 totally. Why these many? In S3 itself, so many. And this is the table. If you look at S3 standard, the first byte latency is in the millisecond. You can start getting the response within milliseconds. Intelligent tiering also milliseconds. But if you go to flexible retrieval, right, your latency would be increasing because this is the even cheaper. Glacier is cheaper. Deep archive is the cheapest. That's why the retrieval time is in hours. It will take hours also to retrieve something. So when we in the Netflix, they mostly use S3 standard. But why these many storage classes? Now tell me, I'm going to ask you a question to make you simple understand. Let's say you have got one S3, we call it bucket. Okay, let's say you got one bucket. Bucket means S3 storage. Let's say you uploaded some 2 GB of data. Could be anything, media, whatever. Let's say out of 2 GB, 1 GB, you're frequently using it. Every alternate days, at least 2 to 3 days, every 2 to 3 days, you're using it. And rest 1 GB, you are not using it from last 60 days or 90 days. Now tell me one thing. Would you want that 1 GB which you're not using to move to a cheaper storage? Would you like that? The data that you're not using 1 GB, right? 1 GB you're actively using, that's fine. I'm not talking about that. The other 1 GB which you're not actively using from last 60 days or 90 days, you have never accessed. Would you want to keep them in the S3 standard or you want to move them in something cheaper storage? Cheaper storage, right? Guys, I'm getting only one response. Can I get some acknowledgement from everybody? It will, I can give you the energy back, guys, if you respond. So my energy would depend on you. Is it making sense for everybody? Right? Others can give me a thumbs up. Guys, please don't nod your head because we are not on the video. Thank you. So yes, cheaper. That's why we have these many storage classes. So there is a rule in S3. If you create a bucket, right, there is a rule. We call it life cycle rule. We can create a life cycle rule and we can give. If let's say because we talk about petabytes of data here, we are talking about a lot of data here. Even 10 cents can make a difference. 10 cents per GB can make a difference here, right? If moved to a cheaper storage. So that's why we have these many storage classes. And the performance wise, as you can see here, the latency, millisecond, I can move this to, let's say if I'm not using any particular content from, let's say last 6 months, I can move this to Glacier, or even I can move to Deep Archive. So I'll tell you one of the example in important use case, the NASDAQ, one of the very important use case of S3. NASDAQ is one of the, NASDAQ, everybody understand NASDAQ? It's the US stock market, right? NASDAQ, like how we have NSE and BSC in India, they have NASDAQ in US. All the trades in the secondary market in US happens at the NASDAQ is the US exchange, stock exchange. So all the transactions records, right? Whoever does the trading, right? Because they have to maintain records of multiple years. So what they use S3 and they use for the data more than 2 years, they put in the deep archive because the storage is cheaper, right? Or in the Glacier, the cheaper, these last two, they move it to those things. Uh, the name itself tells the deep archive. For archival purpose, we use deep archive. Here, the storage is the cheapest. Cheapest, it's going to cost us the least. So if I show you, right, let me show you one. Let me give you one demo of S3. So S3 is the service. So storage, one of the storage service.
Oh my.
Okay. So if I go and create a bucket, we create a bucket in S3. Okay. So I'm going to create a, let's say I'm creating a bucket. The bucket name has to be unique. Let's say I'm going to give my bucket. Let's say I'm going to give some, I need to be unique here. Okay. So 9th March, I can just say 2024. This is mostly unique, right? Let's say I'm going to be mostly unique here. Nobody else would have created this kind of bucket. If I put test sample, those things are going to be very common, right? So I'm creating a bucket. For example, I'm just creating a bucket. Let me create a bucket. And now I can, once I have the bucket, I can go ahead and upload something. So this is my bucket. I've just created a bucket and I can go, what I can do, I can upload something here. I can upload some files, objects we call it, right? Add files. And I can browse my laptop or something like whatever, wherever I have some content, I can just, let's say I have something, let's say I have some objects, some JPEG files. So I can just upload it here and I can check in the properties, I can see here, storage classes, right? Look at the storage classes. By default, they go to standard. So look at the use case they're telling about, frequently access data. If when, because that's the standard use case. And they are for the high availability. Every region, I have created this bucket for a region. Do we understand, guys, region and availability zones in the cloud? So we have got multiple regions, right? And each region has got multiple AZs, availability zones, we call it. So it's all talking about how many copies you have in a region. So in standard, I have got 3 copies. In Mumbai, I'm creating this in a Mumbai, right? This bucket I created in the Mumbai region. Mumbai region has got 3 AZs. So it's whatever I'm going to upload, my copy would be maintained 3 places. If you change that, that's why we call it one zone here, one zone, because the replication is not happening. So the durability, right? Durability could be less here because replication is not there. So I can select this by default. You select a standard, but you can select, and the cost part you can find it. Okay. So if you just go to Google, you can find the cost also, how much it costs. AWS S3 cost. If you see, we can find the cost. If you want, go to pricing calculator. Usually we do that. We go to, let me just give you here, take you here, or you can go to pricing calculator and you can understand 1 GB of EBS cost, how much. But here also in this page, they're giving you the cost. So cost is one of the very important factors that we consider. So look at this. In S3 standard, first 50 TB per month cost this much per GB. If you go and check in the EBS, right, you would be amazed. Okay, it will be much more higher. Per GB, it is costing you this much per GB. Okay, I don't think it's going to be less. It's the S3 best pricing. Okay, because we're talking about petabytes here. First 50 TB. Look at the pricing they have done it, because they know when they're using S3, it's going to be huge data. So per GB, it's costing this much. But if you go to EBS, you're going to find a huge difference. And that's why you have, like, look at the cost difference between S3 standard and your deep archive. You can see the difference here, right? So it matters when it comes to petabytes of data, it matters, right? So obviously the performance also for each, if you look at the performance here, The first byte to latency is very important here. It is in the milliseconds or milliseconds. But mostly we save the amount here if we move the objects to these storage classes. Making sense, guys? So far, EBS and S3, the use case is totally different use case. Did we understand that they complement each other, not compete with each other? Right. So every cloud, so not just AWS, every cloud you go, every cloud. For example, I'll just show you better. I'll give you a better example. If you go to this link, right? I talked about EBS, right? So EBS is the AWS thing. Same thing in Azure. We have it, we call it Azure disks, managed disks here, EBS, right? If you go to GCP, this is the third column is GCP, we call persistent disk, right? If you talk about S3, S3. In AWS, we call it S3. In Azure, we call it blob storage. The use case would remain the same. Either use AWS or Azure or GCP. The use case will not change. What you want to store, that will not change, right? But the naming would change. So we call it blob storage in Azure, cloud storage in GCP. And for other clouds, different names are there, right? The use case would remain the same. Now, the third thing, right? The last storage service is here, EFS, Elastic File System. So Elastic File System operates at the NFS protocol, Network File System. What is the use case here? So to understand this use case, we need to understand the use case of EBS. So EBS we use for the boot volume, right? For each server, I'm gonna draw something. Okay. Let me open a paint to make you understand EFS. You need to understand EBS first better. So what happens when we create a server, right? Let's say I'm creating a server. This is my EC2 instance. And you know what do we use for EC2, guys? Which storage service we use for EC2? Quickly. Who gonna tell? Just now we have discussed. When we create server, what storage service we use for the boot volume? EBS, right? Yes, EBS. Now, both EC2 and EBS, they are at the same AZ, availability zone. In one region, the cloud, how cloud works, right? We have got multiple regions across the globe. And each region has got multiple availability zones. So EC2 and EBS are at the same AZ, always. They cannot be in multiple AZ, okay? They're AZ logged. So tell me one thing. EC2 instance from another AZ. Okay, do we understand AZ or AZ and region or not? First of all, anybody who doesn't understand region or AZ?
Region I understand, sir. And another thing I don't understand.
Availability zone. What do we understand of region?
A region means a specific area where this thing is stored. Like last time you told that in Mumbai there is a three places.
3 AZ. So what do I mean, right? I mean that in Mumbai there are 3 data centers.
Yeah.
That's what each data center is called AZ. So in Mumbai itself, okay, let me talk about that first. So in Mumbai itself, what do we have? We have got 3 AZs. So let's say I'm talking about this Mumbai here, Mumbai region. So usually this is the case with every cloud. Let's say I'm talking about Mumbai here. Similarly, we have 30 more regions, 30 other regions, 30, 34. Yeah, I'm going to give you the exact count. So we have got three AZs, AZ1, AZ2, AZ3. AZs are nothing but the data center. Three locations,
Okay.
right? These are called AZ. AZ1, AZ2, AZ3. Usually in one region, you can have more than three AZs also, depending on your demand and supply ratio. But usually this is the case. Okay. So when I create my server in AZ1, think about it. And these AZs are distance apart. Okay. These AZs are like 200 kilometers apart. Okay. Why they have, okay, tell me one thing. Think about it. Why they have three AZs in a region? 150, 200 kilometers apart. Why they have? Because let's say a flood came in one area. Would you want your other AZs to be also impacted? If all the AZs would be in the same near about, right? So let's say flood came in one part. Think about Mumbai, right? Some three different places, Pune or some 150 kilometers somewhere else, or somewhere else, let's say. If flood came in one area, if all the AZs are together, every AZ would get impacted. Yes or no? Right?
Yes.
That's why this difference is maintained. That's why this distance is maintained. So that if a natural calamity came, my application, I don't get a downtime. Nobody likes a downtime. So what they suggest you to use all the AZs, have your servers in all the AZs, AZ1, AZ2, and AZ3, so that you don't have a single point of failure. You don't have all your servers in one AZ. Okay, that's the point. So EC2 and EBS, when I provision the EC2, and I will obviously I will get the EBS, right. I cannot have EBS in another AZ. Unnecessary, it'll create a latency, right? 200 kilometers. My compute is here, my disk is here. It cannot be like that, right? So they are in AZ log. Now tell me one thing. Can I connect this EBS from another EC2 instance from another AZ? No, right? Just now we discussed. We cannot. Another AZ, we cannot. But I want to access the same data. That is why we have this EFS. EFS is at the region level. EFS we create at the region level. EFS works similar to, it has all the features of EBS. It is SSD. It is even costlier than EBS. EFS is costlier than EBS. So, and we have the EFS at the region level. Think about EFS here at the region level, and one common place, centralized place, where all your EC2 instance from another AZ can connect and get the data. Same data, they can get it. You can have 100 EC2 instances, five here, let's say. You have got 5 EC2 instances here. All can connect to this EFS. EC2 instance from different AZs can connect to the same EFS and they can access the same data. We have this use case in various applications. Let's say one website is there. All the web pages could be in EFS, and all the web servers could be here in different, because I have too much of workload, too much of load. I need many servers. So my mini servers could be in multiple AZs, but all the servers are getting the web page, because web page cannot be different, right? If I'm hitting Amazon.com, my web page, I hit any server I hit, my web page cannot be different, right? So no, they cannot use. No, Pankaj. For EFS, for boot volume, I told you EBS, right? This is another use case. I want to access something at the central level. right? That is why EFS is used. Every EC2 instance already have an EBS. Don't think I'm gonna replace. No, see, don't get confused. Every EC2 already have a EBS, right? Every EC2 instance needs something to host the operating system, right? Everybody has small 20-30 GB EBS where the operating system is installed. But it's all about the website, web server. All the web pages are hosted here. I'm giving you one example. I can hit any server, web server through load balancer. The request can come to any server, but from any server, the web page is getting from here, right? So every server is connecting to the EFS and getting the web page. And then user is getting the response, same web page. Able to understand, guys? So if you want to access something centrally from multiple EC2 instances, where the EC2 instances are at different AZs, what we should use? What we should use in that case? EFS. No, see, Pankaj, to make it better, only I'm using EFS because EFS IOPS is better. It is like EBS. I cannot use S3 here, right? S3 IOPS is not that good. It is EFS is costlier than EBS. Remember it. EFS is costlier than EBS 3 times. Because we are storing at the central level, and for web application, for any use case where all the servers need to connect to and get the same kind of data from different edges, EFS is used. It is like your network file system, Pankaj. Like in on-prem, we have a network file system, right? Pankaj, in on-prem,
Yes.
right? Same concept. Network file system, right? Centralized place. This is what EFS use case is that. So storage area network, yeah, you can anything like SAN, right? Storage area network, right? You're telling.
Yeah.
So at the central location, so you can consider that, yes. Which is that they use the NFS protocol. So that's the use case of EFS in the cloud. You guys making sense on this, everybody? About these 3 services today? I hope we got some insights on the storage services of this cloud AWS. Right, guys. So that will be all, guys, I wanted to cover in this workshop. For more details, guys, we can use tomorrow. You can join tomorrow a demo session about the course. We will go over the course, but this is one of the demo on the storage services. Yeah. Any questions, guys? I have another session from 8:30. Any questions? Quick questions? All good? Okay, perfect then. Thank you so much, everybody. Please join tomorrow for the. So I'm coming up with this course, everybody. So you can join tomorrow for this demo of this course. So I will get all your doubts cleared about this course, about the SRE course, about the topics and everything. Whatever you have, how we cover cloud, Docker, Kubernetes, Jenkins, DevOps. So we'll talk about this tomorrow. Thank you so much, everybody. Yeah, everybody can drop off. Thank you so much.